Hey there, welcome to day 17. In this one, we are going to be creating a data science pipeline using Jupyter, Pandas, and FastAPI. Now, the reason that we want to do something like this has to do with cleaning up the data we web scraped in day 12, but also to learn a lot more about Jupyter Notebooks and Pandas. So let's go ahead and get started. So inside of VS Code, I'm going to create a new folder here called day 17. No surprises there. And I'm going to drag the data from day 12 over. The entire data dictionary. In my case, I have years of data here that I want to use. Now, I'm not actually worried about the scraping part of things. I'm just going to be modifying the data. So this isn't going to be a complete data pipeline. It's going to miss the scraping part, but what we learn here will definitely work hand in hand with what we did in day 12. So if you are wanting the collection of that data, you can go ahead and check that portion out. This is much more about cleaning up that data and then being able to present it in a way that you need to. So let's go ahead and also create a virtual environment inside of day 17. I'm going to go ahead and open up my terminal here, and I'm going to cd into day 17. And we're going to run a pip env install, and I'm going to make sure I have Python 3.8, and I'm going to use Jupyter. So that's Jupyter. Remember that it's spelled a little bit differently than the planet. And I'm also going to install Pandas, the Jupyter and Pandas, and then we also might want to check out Jupyter Lab, which is another cool way to work with Jupyter itself. And we can install Notebook. Now, if you just install Jupyter, Notebook should install. And if you just install Notebook, Jupyter should install as well. But I'm going to be explicit with all three of those things. So as that's creating, I also want to mention that every once in a while, I delete old virtual environments by going to where they're located. Now, of course, using pip env, this will actually show you where they're located. So let's go ahead and do that real quick. I'll just cd into there in my terminal here. And notice that I have a number of these things in here. And to delete them, you can just do rm-rf, and then delete that directory. Or you can just open up whatever the folder that you're working in and just drag that. If you're on Windows, to open it, you just do ii, and that will open up that directory as well. Now, the reason I do this is because, typically speaking, whenever I start a new project, I don't actually always make a new virtual environment, right? I've been doing it for all of these projects, but that's just so you can download any given day and just do pip env install and then run it. It's not really that practical in the long run. But I did want to mention that because some of you have been probably wondering, why am I making a virtual environment for every single day? That seems like a lot. But yeah, so go ahead and delete as many of these as you'd like, just to save space on your local system. And not to worry, whenever you need to run it again, whenever you need to reinstall it, you just do pip env install, and it's going to go off of your pip file and pip file lock. So that's pretty cool. So pip env shell. All right. So what I've got here is I've got data, but typically speaking, I don't actually use the Python shell that often. In fact, even using VS Code and writing Python files, especially when it comes to doing what's called ETL. I'll explain what that is in a moment. But when it comes to actually working with data or CSV files, or specifically Pandas, using the Python shell gets a little cumbersome. And that's where Jupyter Notebooks come in. They actually make doing data science much, much easier. So we type out Jupyter, and then we can do Jupyter Notebook and hit enter. And this will start a Jupyter Notebook server. This is a local server that you can run with. And as you see here, this is it. It's running, looking good. Now, if I were to actually not want to run and use Jupyter, there is a really nice alternative that is free, and it's exactly the same thing. They're the same notebooks, and that's at colab.research.google.com. It will actually provide a very similar environment as Jupyter has, but it's built off of Jupyter. So it works in a very, very similar way. So keep that in mind when it comes to actually doing Jupyter Notebooks, is you can use Google Colab for free. But what we're doing in this one is I want to actually have the ability to have a REST API to actually access this data too, not just simply a notebook itself. Okay, so let's go ahead and create a new notebook here. Click on New and then Python 3. And this is a Jupyter Notebook. So it's just another type of interactive shell. So I can actually do all sorts of things related to Python in any given one of these cells, right? We can say hello world and do Shift Enter, and that will actually run it. Now, the really cool thing about this is I can also declare variables in a pretty interesting way. So if I hit Shift Enter here and then ABC, there we go, right? But then if I say ABC equals to 456, run that, and then come up here and do ABC again, it actually grabs 456, right? So the order of the cells can be moved around, but the way you execute them is still going to work in a logical fashion. So it's going to be first to last, right? So in this case, I did 1, 2, and then this was actually 3, but then I ran this one and then that one, right? So we can actually run these individual cells on a regular basis, and it makes it really powerful to actually write our code, which we'll see in just a moment when we actually start using Pandas. Because I actually don't think that there's a really good example of like using Jupyter Notebook until you actually use Jupyter Notebook. Then you'll really start to, I think, appreciate where it is and why you would end up wanting to use this. I will also say that there is one other thing. VS Code has built-in Jupyter Notebook support as well. So any given notebook that you have, you can open it up in Jupyter and it can actually run it for you, as you see here. Like mine's actually running on its default, and I could do all of the same sort of things, but I'm not going to copy or talk about the VS Code related Jupyter Notebook stuff at this point because it's just kind of redundant information in many ways. Okay, so I actually want to delete this one altogether. I just wanted to show you an example. So we'll leave that, and then I'm going to go ahead and shut this down and delete it. So typically when I actually use Jupyter Notebooks, I create a new directory inside of the running directory, and I rename it to Notebooks. Every once in a while, you'll see it as MBS, but I'll call it Notebooks just to make it nice and explicit. And what I want to do is I want to use Python Pandas to actually load data. So I'm going to call this notebook load data. So I want to grab all of the data items that I had from day 12, and I want to load them in. Now, of course, if I went a little too fast bringing it over, we also have it on our repo. So 30 Days of Python, you can get it in the tutorial reference there to get that exact same data. So what I want to do is import OS, and I want to actually grab the directory that this data is from. Okay, so you might remember that I've done stuff like this where it's like base dir equals to os path dot join, and it was os path dot dir name of the os path dot absolute path of the file, and I actually didn't have the join part there. I did stuff like this, right? But unfortunately in the Jupyter Notebook you actually can't just grab this file. So there's a couple ways you could go about doing this, but what I know for sure is there's something called current working directory, which is os.get current working directory, and we can print out what that is, and that will actually give me the directory that I'm in. So in my case, the base directory is going to be the base day directory, which in my case is day 17, right? So I can just do os path.dir name of my current working directory. Okay. So again, it's the current working directory of this Jupyter Notebook. That is a way to grab, dir name of the absolute path of the file. Notice I did actually remove os.path on those, but that is essentially the same thing, but this is how you have to do it in Jupyter Notebooks. Okay, so now that we've got that, I also want to grab the data directory, and that's os path.join, and this is base dir and data. Of course, I know this because I just did this, but I see that data and notebooks are on the same level of directories, so I can, pretty confidently say that that's the data directory, and I can also do os.list_dir and actually see what data's in there. Okay, so I tried to run this without actually re-executing the cell above it. And this is what you'll see a lot, is these name errors when you accidentally forget to run something, right? So it's a little bit different than the Python interpreter or the interactive shell that we've used before, whereas Python-I and then, something like abc.py. A lot of times we would actually rerun that, or if we actually copied actual content in there, we would actually execute inside of that shell as well. So what you need to make sure that you're doing is hitting Shift-Enter on these cells. So every time you hit Shift-Enter, it's just like running it in the interactive shell. So running these cells is a very common thing that you'll do over and over again. So just get used to typing or hitting Shift and then Enter. And that's cross-platform, of course. So this lists out all of these files here, which makes no surprise, right? So like, yeah, okay, well, there's all those files. How do I actually read them? Now, this, of course, has to do with pandas. So we're going to go ahead and import pandas as PD. So this is a very common expression for importing pandas. Instead of importing it as pandas and using it as pandas, data scientists decided as PD was a nice shortcut to actually call a lot of the built-in methods that pandas have. So when it comes to using CSV files, we use something called a data frame. So a data frame is actually a memory efficient way to load a CSV file into Python. That's what Pandas is all about, is doing this in a very memory efficient way. So just think in terms of, hey, if I want to actually work with a lot of data with Python, Python Pandas is a very good way to do that. There are other ways that might be better, but Python Pandas is probably the most popular and at the top of one of the best ways to do it with Python itself. So how do you actually create a data frame? So we go ahead and declare something like df equals to pd.dataframe. That's a data frame. Okay. I still get that error again. Now, those of you who are paying attention, notice that I did not run that cell. I just need to run that cell. And of course, I already have pandas installed on this virtual environment. And of course, if I didn't have it installed, I could run a command like this, where we do pip install pandas. And this actually runs a command line call for us, right? So that's kind of cool. I'll leave that commented out for now. And I'll come back down here and call this data frame. So a data frame is the CSV file loaded in, essentially. What it means is there's columns and rows, column names and indices, right? So actual numbers for the rows. So what I can do to actually create a data frame is I can send in a list of items, so my items, and I could use Python dictionaries in here and say category, and I'll say action, and then title, my awesome movie. And then do another one and say category and comedy and title. I'll call it dad or data jokes are us. Something dumb like that. Okay, so that's a list of items there, and I can pass this into my data frame. And let's go ahead and rerun this cell. And now to actually look at this data, I can do df.head, call that. And this gives me a formatted way to look at this data, right? Of course, I haven't used the CSV files yet, but I have a way to actually use this data and work with this data. So if I wanted to actually grab, let's say, for instance, the row that's category, I can use df and category. So df is the data frame, and the key I'm using is category. I hit enter, and it shows me the two different categories that actually exist in there, right? So in my case, it's action and comedy. I can do df and title, same thing. I get the actual titles that exist in all of those items, right? So these are actually the row values for that column, right? So it's giving you all of the rows when you call that column. Well, what if I actually wanted to grab the first row, so df0. This gives me a key error, right? It actually doesn't give me that first row. So we can use something called df_iloc, and we use 0. This gives me that first row. This is the location of whatever that first row is, right? If I change that to, let's say, for instance, iloc1, I now get that second row. Not to worry if you're not incredibly familiar with all of these things that I'm doing, because I realize we're doing a lot and we're going through this and you're like, hey, I just learned Python. What are you throwing at me? Don't worry, we'll get doing a lot of practice with this. So even if it doesn't make sense yet, just copy what I'm doing. And remember that to get the actual column, you can use the key that it is, the actual column name. Get the actual row, you just have to use .iloc and then the square brackets like that. Okay, so that's some of the basics. Now, what I want to do is actually load in all of these CSV files. Okay, so let's go ahead and just grab one of them. All right, now the first CSV file, I'll just go ahead and say my data equals to ospath.join, and I'm going to hard code this one in by first grabbing the data directory and then just one of these names in here. Kind of up to you on how you want to do that or which one. I'm going to go ahead and use 2019.csv, and then obviously that's the file itself. So we can just print out ospath.exists and then shift enter to hit it, and true. Okay, so that file actually exists on mine. So now I want to actually turn that file into a data frame. Now your intuition will probably be to say df2 equals to pd.dataframe and then passing in the path to this file. That's been my intuition for a long time as well. Maybe someday this will be supported just like that. But unfortunately, you can't actually pass in a raw file into this data frame. So what you could do is use a different thing called read CSV. So read CSV will actually open up that file and turn it into a data frame in Pandas, much like we did up here, where we actually just turned a list of dictionaries into a data frame as well. So this data type is the exact same is the point here. So let's go ahead and run that. And I want to take a look at the top, let's say 10. I'll say df.head n equals to 10. So again, df2.head in this case. That's the top part of this actual thing here. And I've got an index column. It doesn't show me what that is, but essentially the row index, remember again, the iloc, that's going off of the index number or the row number. And then we've got all of our columns here. And then if I wanted to get the last bit of it, I can use df2.tail. So these are the bottom 10 of that file. Okay, so that's actually loading in the data on a very basic way. And it's just simply read CSV. You'll get very comfortable with using a lot of these commands. So no worries if it's still a little bit of a struggle. I promise you it will get easier. But really the goal of what we're trying to do here is combine all of my CSV files and actually grab this data here and organize it in a way that's actual data. Right now it's not organized in a way that I can use mathematically in any form whatsoever. So let's go ahead and actually load in some more data. All right, so now we can load in any CSV file and turn it into a Pandas data frame. We can also just create a data frame from scratch. So either way, it's pretty easy to make a data frame. So what we want to do now is actually combine data frames into one big data frame, but we actually run into one specific problem, and that is we actually don't have the year associated to any given data set, right? So in 2019, I loaded that CSV file. It doesn't say 2019 in here anywhere. So I want to actually be able to handle that as well, and I'll actually handle that part first. So I'm not going to do it in the load data notebook anymore. In fact, I'm going to rename the load data notebook to 1-load data. I'm going to rename it, and then I'll go ahead and do file, close and halt. And that essentially stops that notebook from running. So if you were doing something like web scraping, it would stop that web scraping and then close down that notebook. Another way to do this is you'll see sometimes an option up here to shut down inside of the tree where all the notebooks are. So what I'm going to do is actually duplicate this, only to have some of the things that were already in there again. So I'm duplicating this, and I'll rename it, and this time I'm going to go ahead and say combine data. Okay. And this is merely for your own reference. It's not meant to have any real logic here, but it is a good idea to separate your data frames. But it is a good idea to separate your notebooks into different names whenever possible and whenever it makes sense, really. Okay, so what I want to do is actually delete a good portion of what I just copied. So I'm going to go ahead and delete even list_dir. Notice that it's blue here, so I actually have the entire cell selected versus working inside the cell. Like when I'm working inside the cell, it's green. When I select on the outside, I'm actually selecting the cell itself, so I can do Shift and down, and then just select all of these cells, and then run, edit, and I can cut the cells, I can copy them. In this case, I'm gonna go ahead and delete them, and now I have just the baseline of what I need. So I also wanna restart this kernel altogether. I'll do restart and clear output. Every once in a while, you're gonna wanna do that. This just kind of gives you a fresh go at it. It's kind of like exiting the Python shell and then re-entering it. And then I'm going to run each one of those cells again. Okay, so if I took a look at what's inside of this data directory, I would see those same files. So what I want to do is just say for file name in os_path.list_dir, or rather os.list_dir of the data dir. I'm going to go ahead and print out the file name itself. Okay, so I've got all these file names. No surprise here. I'm going to go ahead and open one of them and add to that data. So to open one of them, again, we'll go ahead and say df equals to pd.read CSV. And in my case, it's going to be os_path.join the data dir. And let's just do 2010.csv. Okay, so I definitely have that file, so this should work. So df.head, just to take a look at it, there's our data here. Right, so what I want to do is add a brand new column here. Now you may remember to actually select a column, we use just the df square brackets and then the column name. So capitalization, well, let's actually see if capitalization makes a difference. It does. It certainly does. So df.rank or df brackets rank will give me every single rank all the way down to the very last one, right? Or release group, that gives me all of that column, right? But what if I actually tried df year? It gives me a key error. And that's of course because I don't actually have any values in here. So what I can do is I can set this equal to something like 2010, and then now I can go ahead and do df.head and hit enter. Hey, what do you know? I have a brand new column here. So yeah, that's actually creating that brand new column. So I can also say df.start year and set that equal to, notice that I don't have a column called start year, df year, and hit enter, and then df.head. Now I have another column. So that's how you actually copy a column, and you can do cool things in here like multiply it. Right, so you can do various things where it's the entire row. So each row item in there is being multiplied in this case, right? So we can check this by just running it a couple times, actually changing that. That's pretty cool. I think that's actually a really useful thing. We can add a column with default values, or we can add a column from another column's values. Okay, so of course I don't actually want start year in here. I only want year, which is something that I will handle. But in general, what I'm trying to do is actually get all of this data as one single file that I'm going to be working on. So this file that I'm going to be working on is sort of data in process, right? I'm going to not touch this data here. I'm just going to say that that's my raw data. I am not going to touch it. Those are my inputs. and some other process might actually adjust that raw data, but I'm going to assume that these are the truth values. So I'm not meaning to touch these things. Instead, I'm going to put some other data in sort of processing. And now the reason I put this year here is so that it actually references the original file itself. I could also put the file name in there, and maybe that would be a good idea as well. So let's go ahead and iterate and actually create a big data frame after all of this data. So the first thing I'm going to do is run through this loop here. But I'm going to go ahead and say my entire data frame equals to pd.dataframe. Okay, so it's just an empty data frame to start out. And now listing through this directory, I can say CSV path equals to os path.join, and that's going to be the data dir and the file name. Now, I know that this will work because of how that directory is actually set up, but I just want to make sure that my file names are only file names that have a CSV file. So I'll go ahead and make a new one called CSV Files equals to, and it's going to be x for x in os.list dir data dir if x.ends with .csv. Right? So I'm preemptively doing this just in case you accidentally put something that's not a CSV file in that directory. That way I can make sure that I'm actually running through with just CSV files. So then I can feel very confident about going this df equals to pd.read CSV and then that CSV path. And then since I'm actually looping through this data, I'm going to just go ahead and print out this df.head. Okay, so I'm going to run through all of them. I hit enter, and this will actually give me, the first 5 elements, because that's the default for head. If I wanted to change it to a different number, I could do that. But it's going to give me those first n number of items per file. So it's actually loading up all those files, and it's doing exactly what it is that I wanted it to do. So what I actually now want to do is adjust this data frame a little bit. And a couple things I'll do with this one is I'll say file name, and I'm going to set that equal to the file name, of course, the one that's being iterated through inside of here. And then I also want to add the year. Now, in my case, if I scroll up, I know for sure that the year is inside of the file name itself. I can just remove the .csv, and that will give me the actual year. Of course, that's not always going to be the case, but in this case it is. So I'm going to go ahead and work off of that. So the year is file name .replace, and that's going to be .csv and an empty string. Now in this case, whenever you're using Pandas, you don't have to worry about the data types yet. When you're bringing all the data together, the data types, it's nice to actually clean them up and make them right. But as of now, we don't have to worry about that because it's something we will do. What I mean by data type is this going to be a string or an integer? And of course we want it to be an integer, but I'm not going to assume anything here yet. I'm just going to set it equal inside of, my rows here. So this df, and I'll say year is equal to year. And now when I run this, I should actually see file name and year as new columns on any given row. And sure enough, I do. So here's that first row. Here's the first data frame. Here's the second one, and so on. Okay. So now I have a list of data frames. So what I actually want to do is take that list and say my data frames, and it's going to be unordered. No ordering to this. I'll just go ahead and append each data frame in here. So my data frames.append this data frame. So after we added the year in the file name, I'm appending it to that list. Let's go ahead and run that again. It's okay if it prints it out, no big deal there. And then let's take a look at that list now. And there we go. So we have a list of a bunch of data frames. It's showing me some of the values that are in there, which is kind of nice. But now I want this to be my actual entire data frame. So I'm going to go ahead and cut this one out. and paste it here. Now, you might have the intuition to just pass in that list into your data frame. And you can go ahead and just say dataframe.head. And it's not quite what I want, right? It's showing me some sort of data that's going on. So that's actually not how I can initialize it. In other words, you can't make a data frame from a data frame in this way. So there's a few different ways on how you can go about combining data frames into one big one. And it's really simple. It's pd.concat or concatenate, as in combine these data frames. And it's just a list, right? It's a list of data frames. So that's how you combine them. And there you go. So now it's hard to tell if this is correct by just looking at the head. So I'm going to go ahead and also look at the tail to see what the year is. And this tail has a year of 2005. Okay, cool. So with this, I can now save this entire data frame to CSV, just like that. And I want to actually move it from my raw data. So I'll come up here and I'm going to call this data dir and just add another one. And I'll call this cache dir. And we'll put it in a cache. OS make dirs the cache dir and exist. Okay, equal to true. Okay, so I run that. So this cache directory. And then I will go ahead and say the data set equals to os path dot join my cache dir and movies ranking data set .csv, something like that. It's kind of describe this, or movies box office data set. And then we send this to CSV. Okay, I run that, and that should actually output it, which we'll verify in just a moment. Now, the main thing about this is that you want to have all of your data being loaded in, and then we export it to one single source, or this cache source, where I can actually work off of that for whatever the final result is going to end up being. Right, because in its current state, it's definitely not at the final result. I also want to make sure the index is false. I don't need to actually store this index value here, whatever that might end up being, because it starts to get redundant information. You start to get too much index value. So I'm going to go ahead and leave that off. So now I can actually go back into VS Code, look in that cache folder, and I should see, you know, all of the columns as expected. Okay, so you could always open this up inside of like Excel or Pages and take a look at this data too, but notice that I don't have an extra column in here, which would be that index column if I didn't actually save it in the way that I did. So again, the ordering actually doesn't matter yet, but it certainly will matter at some point. So we actually want to clean up some of this data. All right, so I closed down that combined data. I'm going to go ahead and duplicate it, and I'm going to rename this. And this time, we're going to say clean up data. Now, this is also known as transform data. I still have to talk about ETL, but we'll talk about that in a little bit. But clean up data. Okay, so the main thing here is these first few imports, but then also my working file, and that's going to be ospath.join, and that's the cache dir, and then whatever our working file name was, which I had down here, and that's this right here. I can call it dataset if I want to. I'm going to leave it in as working file, just to make it nice and easy on me as to, for sure, this is the file that I'm working on. So let's go ahead and delete all this. Okay, so deleting all those cells. And I probably don't need the install cell anymore either. Okay. So now I'm going to go ahead and load in my data frame. So pd.read CSV and working file. All right, so we'll go ahead and do df.head, and I'll do, I don't know, some really large number that I want to display here. I just want to verify that I have years and basically different years going through, right? And I already see a red flag that should stand out to you as well. This far left column is the index value, and right next to it is the rank. Those numbers should actually add up to being roughly the same. They might be off by 1, and they probably will be because the index will start at 0 where the rank will start at 1. But I actually want these to be ranked correctly, right? So the rank numbers are currently invalid. So there's a couple of things that I can do for this. I can actually delete the rank file altogether. In fact, the rank column I have to delete altogether because I need to actually change all of these things. So instead of actually deleting it, I'll just go ahead and say df rank, and that's going to be equal to -1, meaning they're not actually set yet. So df.head. And that's just a nice, easy way for me to remember that none of the ranks are set yet because all of this data is incorrect, right? So the percentage of sales, percentage of foreign, all of that, none of that data is correct at all. So the other part of this is these two items are named incorrectly too. Now, I did mention in the web scraping, there's probably a cool way to do it with just the web scraping part, but I don't need to worry about that now. What I need to do is just rename these columns to make sure they are the correct ones. Now, I could do the math to find out which number corresponds to which, but I actually already know that the domestic number, this should be domestic percentage, and this foreign number, this should be foreign percentage. So now I'm going to go ahead and change those. So df and domestic percent is equal to df percent, and df and foreign percent, or not ampersand, but percent equals to df, and this is %.1. So really cool. Pandas by default actually adjusted the names of these columns because they were the same column names, but the values were different. So Pandas actually helped us there. So now I can again do df.head, and what I'll see is a few more columns, but they're a little bit closer to what would be accurate. So I actually want to get rid of these two columns now. So to do that, I can go ahead and call df.drop, as in drop columns, and then the names of the columns I'm trying to get rid of. In this case, it's % and %.1, and I can pass it in as columns like this. That's one way to write it. I can also pass in the axis value of 1 and pass it in like that. So either way, that's going to go ahead and drop those columns out. And then I see the result from that. Those columns are gone, and the new columns are renamed accordingly. So if I do df.head now, what the heck? They're back. Well, a lot of times what you'll see whenever you're doing, whether it's a drop or some other things, you actually want to call something called inplace equals to true, or you just need to reset the data frame itself. So I would just reset it like this. Now, the reason it doesn't do that by default is because every once in a while, you might want to set a new data frame, right? So I could say new df is equal to that. And that way, it doesn't actually remove some of that original data. No worries if that's not all kind of falling in line. Let's just go ahead and make sure we do in place. And then that way, it definitely drops out those columns for me. Okay, so now what we need to do is actually convert these numbers into their actual integer representation. In other words, I need to get rid of the $signs and change them into actual numbers. $signs and the commas, get rid of both of those things and turn them into actual numbers. So I need it to change. So one way to do this is by actually grabbing any given column, so worldwide, and setting that equal to df worldwide, and then doing replace $sign with nothing, and replace comma with nothing. Now let's look at that. So df.head, we hit enter. What happened? Didn't actually replace it. Okay, so that's actually not a valid way to do it. This seems like it should work, but unfortunately it doesn't. Now, what apply allows me to do is df.apply. I can actually run a function in here. So I'll go ahead and say define clean column. And this function, we can pass it into this data frame. And we can do it where it's cleaning row by row. And to do that, we pass in axis being 1. So when I pass axis being 1, that means that the row is actually passed in as an argument. Now let's actually take a look at the row, and then we'll actually return the row as well. So you definitely want to return the row from here. I run that, and I get row line by line. A row is just is called a Pandas Series. So Pandas Series. And a data frame is just a collection of Pandas Series. So each row is a Pandas series, which means that a lot of the same things I can do on a data frame I can do on a row, such as getting an individual column. So like I did row worldwide equaling to row worldwide dot replace the $sign and an empty string, and then dot replace, and we said comma and an empty string as well. This will actually change those values. I'm not going to print out the row this time, but rather I'll just print out df.head, hit enter. So it goes through each row. This is where you can do all sorts of methods here. So let's say, for instance, you need to do an API call to grab additional data. You can absolutely add additional data to a row right here as well, which is pretty cool. Actually, let's not print df.head. Let's actually just run df.head so I can see it. And I'm still not seeing any real values here. So what I want to do is actually reset the data frame from this and now run it. And I see that now my worldwide is a different value than it was. Now you might be wondering, well, hey, up here I did, df.drop, and then I did in place equaling to true. Unfortunately, apply doesn't work as well using something like in place. It makes actually a lot of sense to actually create a brand new data frame or reset your other one. So another way to think of this is just to say df2 or df cleaned. That's actually probably better, right? So we have our initial data frame and then now our cleaned data frame. So I actually want to reload that initial data frame for this reason. And oftentimes you have to reuse data frames over and over again, and I don't want to delete the old data after I clean some of this new data. In other words, df.head is still the same data, and df clean or cleaned is the different data, right? So it's the new cleaned data, if you will. Okay, so now that I have this clean data frame, there's additional rows that I actually need to change here. So what I can do is I can actually grab a column list, right? So I can go ahead to clean calls or to clean columns. This is going to be, worldwide, as we saw there. And then the next one would be domestic, and then foreign. Okay. So with that, I can actually iterate through it and say for call in all that, and just actually use something more like this. Okay. So this is cool that I can actually run that, but another idea that we need to have is I actually want to have a specific method for this. So I'll have a method called, let's say, convert to int, and this is going to take a string value, or let's go ahead and say currency value, and then it's going to return some sort of currency value. So I'll say currency string to integer, and that should actually return this replacement stuff right here. So come in here and say Okay, so I'll just call this current value actually, and return back the currency value. That means I can run this method around that individual column declaration. Of course, if this is confusing at all, we'll say current value equals to that column, and then we can convert it and then reset it right here. Okay. So all this method does then is actually replace that value. So that also means that I can potentially have some errors or issues with how this is currently working and change those in line in that function itself versus in this clean column row. Because the other thing is, if I have other columns in here that I want to clean as well, I could do that inside of this clean column function itself. So let's go ahead and take a look again. It's running through, and now all of those columns are cleaned and they look a lot better. So another cool thing about this is, since I have this currency value, I can actually run something like this where I want to convert it into an integer itself. So I can go ahead and do accept currency value equals to 0. Okay, so let's try that again. And so now if there aren't actual currency values, then or actual number values, then I can just remove them or put them in as 0. So I have actually seen that in this data. So I'm not going to go ahead and look for it, but I do know that some foreign value was with this, just this dot here, or this slash, or dash rather. So if we look in the original data, I'm going to go back to like maybe 2005, and like towards the bottom, you'll see something like that slash. Here you go. There's a couple numbers right there that give you that slash. So what I did here was actually just convert those into a 0. So this just takes any row value with a dash and turns into 0, which is accurate in this case. Now that's not the only way to do it, but it's kind of a clever way to do it in the sense that, hey, I'm already doing this conversion with these numbers. I might as well also do the conversion with some of the other invalid numbers as well. And instinctually knowing this will come over time, right? You'll start to learn that this is something that you'll need to do because of this next part. So now that we've got all of that cleaned, if I do df cleaned.dtypes, this stands for data types, I can see now that I have integers here, which those should be integers. And if I looked at the original df or the original data frame and look at those data types, d types, I see that all those numbers are objects, right? And if I actually didn't convert them in here, I would still see objects, right? So if I didn't turn them into the integers, which actually, let's take a look at that. I'll comment out this try block here, and then we'll look at those data types, and they're still objects, right? So there's a way to convert them into something that's not an object, but this is a very simple way to do it. Now, this sounds probably a little tedious and stuff like that, but it is actually important that we're using the right data type so we can do math on it, right? So if you remember with Python strings, if you multiply Python strings, you just get that string however many times you multiply it by. Now we actually have integers that we can run with and actually use to change some other data. And with that, we want to actually reset this rank number based off of the worldwide data. Now, if you're not familiar, domestic, of course, means US, and foreign means anything outside the US. Those numbers combined will give me worldwide. In some cases, domestic will be 0. In some cases, foreign will be 0. And I know this because of what I did up here and how I cleaned it up, but also in some cases, it will actually be reported as 0 as well. So what that means that I need to do is actually resort the entire data frame. So once I resort it, then my index values will be corresponded to my worldwide numbers, or at least that's the hope. And then we will reset the rank based off of the index values plus 1, because index will always start at 0, and we want rank to start at 1. Okay, so the first thing I need to do is actually sort these values. It's actually really simple. We use df cleaned and then sort values, and then we pass in the argument of by and whatever column that we want to use. So the column in this case, of course, is worldwide. And then I'm also going to do in place equals to true. And they'll do df cleaned .head. Okay. And it's giving me a key value error for worldwide. Must be lowercase. There we go. Oh, and another spelling error. Oops. Okay, so I have now resorted them, but they're in the wrong order, right? So what I want it to be is actually descending order. Right now it's in ascending, so it's going from lowest values to the highest. So I want it to be from highest values to lowest. So there's only the argument or the possibility to say ascending equaling to false. That means it's descending, so it's the opposite of that. So refresh that, and there you go. But notice that my index is incorrect, right? So I have reset this, but my index values are not reset. So what we need to do then is actually reset the index, and that's really simple. df cleaned.reset index, and in place being true, and then df cleaned .head, hit enter, and there we go. We reset the index. What the heck? What's going on here? Well, that's giving us a new index value. So we also want to drop the original index value, right? So that's essentially saying, hey, it's creating a brand new column for me for their original index values. So the original indices are actually really nice to have, so you can see where things shuffled around if you need to. In my case, I do not need to, so I'm going to get rid of it, and it's actually not giving me that dropped value, right? Because it already added it. It added it as a new column. So I can actually run through all of these things again, as in I can recreate that df cleaned method here and come down to actually get what would actually come out at the very end here, which is this right there. So I certainly want to reiterate that these box office numbers are only from like 2000 and later, and then they're also not adjusted for inflation at all. So it's possible that some of these might be shooken up a little bit based off of inflation and all that, which it's hilarious to see that Lion King movie is number 5. Anyways, so let's go ahead and now actually reset this rank. So I want to set it based off of the index itself. So I can go ahead and use df cleaned and rank, and this is going to be equal to df cleaned .index plus 1. And then we'll go ahead and take a look at that. There you go. So in this case, I didn't actually have to use the apply method because I wasn't actually modifying the rank itself. I was using another column and then adding to it. Like I wasn't changing each individual column value. I was just grabbing and copying another column and then adding to it. So you could definitely use apply still. It doesn't have to not use apply, but in this case, I'm just going off of the index value and then adding 1. And this is also nice because if I actually wanted to change how I actually sorted the values, I could do that. And then the rank, you just run a few more cells and then we would actually get that actual rank value as well. Okay, so the actual final thing that I want to do with the transformation is the domestic percent and the foreign percent, right? So this is also going to come from df apply, or is it? Well, let's actually see a few things that we can do with the math, right? So if I did df cleaned and my worldwide numbers, so worldwide divided by df cleaned and domestic. I'm actually getting values there, right? So, oops, got those values backwards. There we go. So the very first one is 30. Well, if I rounded it up, it'd be 30.7. Hey, what do you know? 30.7. So that's actually the domestic percent. That's really simple. Domestic percent equals to that. And I'll actually replace what's currently there. So that's the domestic. And then the foreign key, the foreign percent is here. And those numbers are going to be the same, but the data types have changed. They're going to be the same as in, that's still the correct percent. Those are still the correct percentage numbers. They're a little bit closer to accurate. Actually, they are much closer to accurate because they're not rounded other than maybe the last few decimals, but that's okay. Those are really tiny numbers when it comes down to it. So that's cool. And then what I can also see now too, if I scroll down a little bit, is the actual data types for this. I hit enter. I see that those are now float numbers. They're no longer objects. All right, so release group is really, that's the title of the actual, the title of the film itself, but I'm not going to worry about that either. All I want to do now is actually store this to being from the working file to being box office data set and now dash cleaned. And this is going to be the output file. So we'll scroll all the way down and now df cleaned.to CSV, that output file, index being false. I do not need that index value because I have my ranks in there. And I certainly do not need a whole new column every single time I output this or import this. So doing index being false is actually really, really key here. And oh yeah, so I didn't define it, or I didn't actually run that cell after I defined it. So let's make sure I run it. I love doing that. I do it a lot. Then I run that again. Now let's go ahead and back into VS Code, into our cache folder, and cleaned file. And now this should be a lot more accurate. So we can go to the very bottom. There's been 10,000 movies, 10,102 movies from today since early 2000, right? Which is really interesting. We'll probably see a number of 2020 movies because of all this quarantine lockdown stuff. But we'll also see a bunch of movies that just never did that well. Like a 2013 movie called Absence. Looks like it didn't make a whole lot of money. $1,031. That's crazy that was like a major release. No disrespect to that movie. I don't know anything about it, but it's weird to see those low numbers when you always see these huge numbers of these movies. But the other thing that's also really interesting to see to me is that there's only been 10,000 movies in 20 years. That's like a really small amount, right? Like I think on YouTube, there's probably like 10,000 a second that are being uploaded. But anyways, that's cleaning or at least transforming the data. So now that we've got this, let's go ahead and move to the next part. As far as data science is concerned, we actually did all of the ETL, or extract, transform, and load. Extract means actually doing that web scraping or pulling the data together. Transform means to clean it up and get it ready to actually being used. And then load is to actually put it somewhere that we can use it, right? So in my case, it's the movies box office dataset cleaned.csv. Now you could also use a database. You could store this into a database or a data lake. But what I also want to do is actually turn this into its own REST API by using the FastAPI service. Now, I've already done some stuff on this, and there is another thing that you might check out, which is on invictify.com/GitHub, and you can see the Jupyter Notebook REST API there. It's very similar to what we're about to do, but you can actually run your Jupyter Notebooks themselves. Like you can actually trigger any of those notebooks that you had, including the web scraping portion, so you can create that entire data science pipeline. But I'm going to go ahead and use the Fast API just to display this data so you can see how that's done. So going back into VS Code, I'm going to go ahead and do pip env install Fast API and UV unicorn. And I'm going to go ahead and let that install. While that finishes installing, I'm going to go into my day 17 here and I'm going to make a file called server. Inside of this file, I'm going to make a new file also, and I'm going to call this main.py. And inside of here, I'm going to go ahead and do from FastAPI. We're going to import the FastAPI class, and we'll just say app equals to FastAPI, and then app.get. And I'm just going to put this on my index page here, and I'm going to go ahead and return. I actually want to return the data. Actually, maybe we shouldn't put it in this index. I'll just go ahead and call this read root. So I'm copying a lot of their, default setup here, hello world. And now I'm going to go ahead and say app.get, and I'll call this box office. And this one I need to, read. This is going to be the box office numbers. Okay, so this is going to have to return my box office data. So naturally, I need to grab the base directory of day 17. So we need to import OS, and we'll go ahead and say base dir equals to os.path.dirname, os.path.absolutepath of this file. Close that off, and data dir equals ospath.join base dir and data. I actually probably don't need data dir, but rather the cache directory, cache dir. Okay, and then the actual output file was cleaned, so I'm just going to right click and hit rename just to copy the entire thing back in main.py, and we'll say dataset equals to ospath.join cache dir and that file name. And then I need to import pandas, so import pandas as PD. And so I want to read this data frame here. So I'm going to go ahead and set the data frame in the function itself. So pd.read CSV, and it's going to be the dataset itself. Okay. I can leave the index in there if I'd like. Doesn't really matter. And then I'm going to return df.toDict, and then I'm going to use the column of rank. That way it orders it in the rank, and it actually gives it based off of rows and whatnot, just like that. Okay, so now that I've got this, what I need to do is actually run this server. So inside of server, I'll go ahead and do run.sh. And of course, if you're on Windows, yours is going to be run.ps1, Windows PowerShell, that is. So I need to just run UV unicorn, and that's as simple as UV unicorn, and that's going to be main app. And I'll do -- reload. Save that. PS1, I'll put that same thing. And then run.sh, I'll go into cd server and chmod +x run.sh. And then let's go ahead and run.sh. Looks like I don't have the, I spelled UV unicorn incorrectly. Let's try that again. There we go. So I got that worker process going. I should see hello world. And then I called it box office. What did I call it? Box office. Just box office. Okay. I hit enter. You get a server error. So it's saying that this file does not exist. Okay. So no surprise there. The problem is with this base directory. I'm actually getting the dir name of server, not the day 17. So ospath.dirname of that. This should give me day 17 or, /day 17 directory. And once I save that, refreshes for me. I reload this, and there you go. So you're actually getting JSON data back with all of that information, right? It's really big. So, of course, there's definitely more efficient ways to load this data in. But the purpose of showing you this was to show you that you can use df.toDict, as in toDictionary, based off of one of the columns, And in this case, it makes the most sense to use rank because then it does the descending rank, or rather ascending rank, but descending numbers as far as the worldwide box office is concerned there, right? So it now has a way to load this data with a actual REST API. And of course, if you went through day 12, you can see how to actually turn this into its own public endpoint using ngrok.com, using this so you can actually expose this endpoint to the web if you needed to. But of course, this is meant to merely show you that you can load this in. Now, I would say that this is not going to be the most efficient way to display this data in a REST API. You'd probably be better off using a production grade database like a PostgreSQL database or a MySQL database than loading in a CSV file in this way. It's just not going to be nearly as efficient. But that doesn't mean that you can do it and it wouldn't necessarily work and work well. FastAPI makes that incredibly simple as well. All right. Hey there, thanks so much for watching day 17. I realize we only scratched the surface of what you can do with Pandas and with Jupyter. But both of these packages I think are amazing and definitely well worth your time to learn more about. Now, I wanted to show you something as practical as possible so you can see the real benefit of using these tools, because doing it in any other way would have been a little bit more challenging. Now, using something like VS Code does allow us to run Jupyter Notebooks, and it is cool to check out how that works as well. Of course, I encourage you to do that. But by and large, you're going to see a lot of data scientists using Jupyter Notebooks as we have here. There's another thing called Jupyter Lab, which does essentially the same thing. It runs these Jupyter Notebooks. So that's also really cool. In Pandas itself, well, we only showed you some of the feature sets that Pandas has. And really, we used a very clean data set. What happens when the data gets a lot more challenging? Well, that's when learning more about Pandas becomes very, very important. So I definitely encourage you to do so. So thanks again for watching, and I hope to see you in the next one.